Good evening, everyone. Good evening, everyone. I hope I'm audible to everyone. Hello, everyone. Good evening, Satvik. Good evening, Ramcharan. Lakshmi, good evening. Hi. Good evening to everyone. Okay, so good evening, Sandeep. Incognito. Who is this incognito? Miss Incognito. Okay, so I hope in the last class you have understood the density ka concept. Do you want me to? Okay, I'll quickly go through it once. So in the last class for the density, what we saw is in the concept of density, for the gases I'm talking, for the chemistry I'm talking, there are two types of density. One was for, one is absolute density, right? Very good, absolute density. And what was the formula of absolute density? Absolute density is rho is equal to pressure into molar mass of the gas by R into T, right? So this was the formula of the absolute density, yes or no? And what was the formula for relative density? So relative density is known as vapor density for the gases, right? And vapor density we derived that it is equal to mass of gas by 2, because vapor density is the relative density with respect to what? With respect to hydrogen gas, yes or no? Therefore vapor density ka formula comes mass of gas by 2. And this we have done the derivation already, right? Vapor density we denote by small d, and absolute density we denote by capital D. Okay. Now, sorry, this was not the capital D. I think in absolute one, in this one, vapor density were again divided into two halves, right? Vapor density was again divided into two halves. One density was, in vapor density we have two parts, right? One was for pure gases, and one was for mixture of gases, isn't it? One was for pure gases and one was for mixture of gases. And if you remember the derivation, for the pure gas, vapor density capital D is equal to mass of gas by 2, because there is only one gas. But for the mixture of gases, we saw the density ka formula is effective molecular mass, effective molecular weight or whatever, by 2. Effective molecular weight by 2, and we have learned how to calculate the effective molecular mass. We have seen already, right? Then I said that vapor density is not equal to density. So this is density which is absolute one, rho, and this one is vapor density, and of course both are different. Vapor density is not equal to density. So I said that find a relation between what? Find a relation between density and vapor density. Because we are having two types of vapor density, one I'll have a relation for, let us say, pure, and in one we will have a relation with vapor density which is mixture, okay, mixture of gases. So for the first one, which is pure, what are the formula, Bhulabhataji? What are the formula? Can you give me the formula? So capital, rather I'll write rho, because it is absolute density rho, which is equal to P into M by RT. Now, for the vapor density, I know the formula for the vapor density is, bolo beta ji, vapor density capital D pure ke liye, mass of gas by 2, molar mass of the gas by 2, right? Very good. P into 2D by RT. So for pure one, formula is P into 2D by RT for the pure one, and for mixture of gases, the formula comes out to be pressure into 2D by RT. Yes, I hope this is clear to everyone, right? Just give me a thumbs up so that we can carry forward. I hope this is clear to everyone. Yes? Guys, give a thumbs up so that we can continue. I hope this is clear to everyone. All of you are comfortable with the density now. Yes? Okay, so once we are comfortable with the density, now today we are going to start something called as percentage composition. Again, this is very, very important. See, the nature of mole concept is as such that not necessary that we are going to use the mole concept, or rather I will frame like this, in JEE exams may not we are having the question directly from the mole concept, but if you don't know the mole concept, you won't be able to do physical chemistry anyway, we won't be able to do inorganic chemistry, and we won't be able to do organic chemistry. These days, especially in JEE advanced papers, they are always merging the idea of mole concept into the organic reactions and inorganic reactions. So if you don't have good idea about mole concept, every thing will become difficult. Yeah, you say always important topics. Yes, Lakshmi. That is why I have chosen all the topics which are very, very important, which is going to be used. That's why we have chosen these kind of topic. Okay, Lakshmi. Okay, I hope that was not the sarcasm from your side, Lakshmi. Okay, so now, so we are going to study something called as percentage composition, right? So what is percentage composition? Percentage composition means what? Let us say that I'm sitting in a classroom, okay? I'm sitting in a classroom, and let us say with me 10 other students are also sitting, okay? So I'm the teacher and 10 students are sitting in the classroom, or let us say 198 or 200 views currently people are watching. So now these many masses, right? My mass, let us say I'm 65 kgs. So everybody is having some kind of mass, yes or no? So now I want to measure what is my contribution in terms of percentage in total mass. In the total mass, what is my contribution, right? So let us say my mass is 65 kg and in number I am only 1, yes or no? So my mass 65 kg, and let us say the students and me combined, let us say total weights comes out to be 1000 kg. So what is my composition? What is my composition? What will be my composition? Mass of mine, right? And because I am in number only 1, so 65 into 1 by total mass multiplied by 100. This is my percentage contribution or my percentage composition in the mixture of student and teacher, isn't it? So my contribution is this much. So this is my percentage composition. Similarly, let us say I want to know percentage composition. Let us say I want to know percentage composition of, let me take one example. Let us say I'm taking magnesium nitride, okay? So I'm taking magnesium nitride. All of you know how to do the crisscross. This is +2 and nitrogen -3. If you do the crisscross, the formula comes out to be Mg3N2. Now, let us say we are having this 1 mole. 1 mole of magnesium nitride we are having, okay? So if we have 1 mole of magnesium nitride, now we want to know what is the percentage of magnesium in the compound and what is the percentage of nitrogen in the compound. That is known as percentage composition. Now in percentage composition, we are saying that percentage composition is nothing but it is percentage by mass, not by volume, not by anything else. This percentage composition is percentage by mass. Okay, percentage by mass. So what is percentage by mass? Total mass of the compound. Let us say I want to measure the percentage of magnesium. So in 1 mole of magnesium nitride, I am having 3 moles of magnesium, right? In 1 mole of compound, I am having 3 moles of magnesium, and 1 magnesium ka mass is how much? 24 grams, right? So 1 magnesium ka mass, 1 mole magnesium ka mass, 24 grams. So how much in this compound is magnesium? So magnesium is 72 grams. And what is the total mass of the compound? So this is 24 into 3 grams for the nitrogen plus nitrogen, sorry, this is for magnesium. And for nitrogen what it will be? So 2 into mass is what? 14. So percentage of magnesium is total mass of magnesium divided by total mass of the compound into 100, isn't it? So whatever value comes, that is the percentage of magnesium. That is the percentage of magnesium. If you have calculated, somebody has already calculated, I don't know the answer. Can you do the calculation for me, everyone? Can you do the calculation for me, everyone, quickly? 72 plus 28. So it is 100, that will be cancelled out, right? So this will be exactly 72%. Okay. So this is coming out to be 72%. So what will be percentage of nitrogen then? Either you can directly see, total percentage will be always 100, right? So I can directly write 100 minus 72, which is equal to 28%. Or I can write percentage of nitrogen is equal to, what is the, bolo beta ji, percentage of nitrogen? So 2 into 14, which is 28, by magnesium nitride ka total mass we have calculated 100 grams. So this is gram into 100. Right? So percentage comes out to be 28%. Is this percentage composition clear to everyone? Give me a thumbs up, guys. Is this clear to everyone? Let me see. All of you understood what we are doing in percentage composition? Can we go for the formula now? All of you understood? Give me a thumbs up, guys. Let me see. Is it clear to everyone? This concept of percentage composition, what I mean by percentage composition, is it clear to everyone? Okay, great. Now, let us come to the formula. What will be the formula? Let us say we are having a compound AXBY and we are having 1 mole of AXBY. So percentage composition of any element in a given compound, is equal to what? Number of mole of that element, multiplied by what, bolo beta ji? Molar mass of that element. Molar mass of that element divided by molar mass of the compound. Divided by molar mass of the compound into what, bolo beta ji? 100. So this is the formula for percentage composition of any given element. This is the formula for percentage composition. Is this clear to everyone? This formula clear to everyone? Bolo beta ji. Is this formula clear to everyone? For example, if you write percentage for A, right? Percentage of A will be 1 mole. So 1 mole of the compound will have X mole of A, X into 1. 1 mole of compound will have X mole of A. So this will be X mole into what, bolo beta ji? Into molar mass of A, divided by molar mass of what? AX BY into 100. So this is the percentage of A. I hope everybody has understood what is percentage composition. Is it clear to everyone, guys? Is it clear to everyone? I'll repeat. If you're not understanding, I'll repeat what it is. Percentage लिख देता हूँ बेटा जी, चलो. Actually my handwriting is not very good, but okay. Listen to the class carefully, you'll understand. Okay, I'll write. Percentage composition of any element in a given compound is equal to number of mole is equal to, listen carefully beta ji, number of mole of that element into molar mass of that element divided by molar mass of the compound. Look at here beta ji, look at here. Okay, I'll take one more example. If some of you have not understood, I'll take one more example. Okay, let us say that I'm having one more example. Chalo. So let us say I'm having 1 mole of methane molecule. 1 mole methane molecule I'm having. If I'll have 1 mole methane, so 1 mole methane. So for 1 mole methane, can you give me the percentage of carbon, please, all of you? Can you give me the percentage of carbon for 1 mole methane, please? Give me the value. What will be percentage of carbon for 1 mole methane? For 1 mole methane, what will be percentage of carbon? Give me the value, please. For 1 mole methane, 75%. Okay, very good. Concentration? Percentage composition or concentration? 75%. Okay, so you can do for 3 elements also better. Let us say somebody is confused, sir, how to do it for 3 elements. Okay, let us say we are having sulfuric acid. First I'll do for percentage of carbon for methane. So percentage of carbon. For 1 mole compound, we are having 1 mole of carbon into what is the mass? 12. Divided by total mass is how much bolo beta ji? 16 into 100, which is equal to nothing but 75%. Yes or no? For H2SO4, let us say we are having sulfuric acid. Give me the percentage of hydrogen, guys. So this is 1 mole sulfuric acid, okay? So this is 1 mole sulfuric acid. Can you give me the percentage of hydrogen for this? Percentage of hydrogen. Percentage of hydrogen for 1 mole of sulfuric acid. I have taken 3 elements now. Some of you are confused. Approximately 2. 100 by 49. Yes, very good. Revati, very good, beta ji. 100 by 49. Very good. Very simple, right? So percentage of hydrogen, 2 into mass of 1 hydrogen, which is 1, divided by total mass is 98 of the compound into 100, isn't it? So which is equal to 100 by 98. Okay, 249, so 100 by 49%. I think very easy. All of you have understood what is the percentage composition idea. Very, very simple. Now, by the use of percentage composition, what is percentage composition? Please remember. Percentage composition is percentage by mass. It is not percentage by volume. It is not weight by volume. This is weight by weight. Percentage mass, very simply, it is weight by weight. Okay. Now, so once we have understood this, percentage composition, now with the help of percentage composition, we are going to derive something which is called as empirical formula. Which is called as empirical formula. So there are 2 terms. Now, if you want to understand what is empirical and molecular formula, this is very important that we have the idea about the percentage composition to solve the numericals. Okay. So what is empirical formula and what is molecular formula? So there are 2 terms which are used, empirical formula and molecular formula. Empirical formula and molecular formula. So what is the relation between them, sir? I don't understand. Can anybody give me the difference between empirical formula and molecular formula? Any one of you can give me the difference between empirical and molecular formula? Anybody can give me the empirical formula and molecular formula? What is the difference between them? Bolo beta ji, what is the difference between empirical and molecular formula? Simplest form of compound. Okay. Anybody else? Let's see. Can you give me the difference, beta ji? Represents the simplest whole number ratio. Very good, Jitendra. Molecular formula shows the actual number of each type of atom in a molecule. Very good, very good. Okay, so now I'll take one example. Let us say I'm taking the example of glucose. Okay, let us say we are having glucose. I'll write over here glucose. So if you remember, the formula of glucose is C6H12O6. C6H12O6. Now remember, in the nature, in the atmosphere, in the nature, glucose is found in this number only. What I mean is, if you look at the glucose, there are 6 carbon atoms. If you will take one molecule, 6 carbon atoms. But if you will take 1 mole, this will be 6 mole of carbon atoms, not 6, huh? Please remember. So let us say I'm having 1 molecule. So for 1 molecule, 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. That is how glucose actually exists in the nature. So actual number of atoms in any given compound gives the idea about the molecular formula. So C6H12O6 is the molecular formula of the glucose because it represents the actual number. These are the actual number which is actually, that is how the glucose exists in the nature, okay. So actual number of atoms in any given molecule. In any given molecule. Right? In any given molecule. What about empirical formula, sir? Tell me empirical formula. So empirical formula is the simplest whole number ratio. Is the simplest whole number ratio. It is the simplest whole number ratio. What I mean by simplest whole number ratio, if you look at the glucose, can I have a simplest whole number ratio? Yes, I can have. If I divide by 6, this will be CH2 and O. This will be CH2O. So this one is the empirical formula of the glucose. This is the empirical formula of the glucose. Okay. This is the empirical formula of the glucose. Very easy, right? You can have more examples. Let us say I'm having the formula benzene. Okay. Benzene. So what is benzene? We all know that benzene ka molecular formula is C6H6. Benzene ka molecular formula is C6H6. Now, what will be the empirical formula? So take a simplest whole number ratio, that will be CH. So CH is the empirical formula and C6H6 is the molecular formula. So molecular formula gives me the idea about the actual number of atoms for any given molecule, while empirical formula gives us the idea about simplest whole number ratio in that molecule. Okay. Now, we are going to solve few questions how to find out empirical formula and molecular formula. Okay, let us follow. So I'll start with very simple problems actually, and then we will go for the difficult ones. Let me see, do I have one very simple problem was there? Let me see. Okay, so we are having this question. Determine the empirical formula of a compound having the following percentage composition by mass. Now this is very favorite question of JEE mains. Okay, why is it necessary? I am telling you, beta ji. I am coming to that. Why is it necessary? We are coming to that. So now we have to find the empirical formula of a compound having the following percentage composition. So how we are going to solve these kind of questions? Please listen very carefully. So what is the first step? Step number 1. Step number 1, you write the atoms like this in the table. So what are the elements we are having? We are having phosphorus element and we are having oxygen element. Now, phosphorus ka percentage of phosphorus, total will be 100%, right? Phosphorus ka percentage is how much? 43.64%, and percentage of oxygen is equal to 56.36. Now, whenever we are dealing with the percentage, it's very easy to assume the mass. I don't know what is the mass of the phosphorus. I don't know how much of phosphorus is present in the dabba, in the container. We don't know. But if I assume that total mass is 100 gram, total mass is 100 gram. If you assume total mass is 100 gram, suddenly this percentage becomes gram. For example, let us say that I have got 50 marks. Now, or let us say I am saying my percentage of the marks is 50%, right? Now, if I assume that total percentage, listen carefully, I am saying that I have got 50%. Now, you want to know what is my marks, actual marks, not the percentage, you want to know the marks. But if I assume that total marks is 100, so 100 is 100%. So suddenly 50% becomes 50 marks. So in terms of percentage, it is very easy. 40%, if you assume total marks to be 100, 40% becomes 40 marks. If I am having 90% and you want to know what is the actual marks, so you need to assume the total one. If you say total marks is 100 marks, so 90% is 90 marks. You can have double also. Let us say I am having 50%. If you assume total marks to be 200 marks, now 50% will have 100 marks. But we don't want to complicate. We want to make it as simple as possible. So we will always assume total to be 100. Percentage by mass is given. This is percentage by mass. So it is related with mass, isn't it? So because it is related by mass, I will assume total mass to be 100 gram. You can take any other mass. I am assuming, to make the calculation simple, total mass to be 100 gram. if total mass is 100 gram, suddenly mass of phosphorus will be, what will be mass of phosphorus? So mass of phosphorus will be 43.64 grams. So this is the mass of phosphorus when we have assumed total mass to be 100 gram. Is this clear to everyone? Just give me a thumbs up, guys. Is this clear? This idea is clear to everyone? What I have just now said. Is it clear to everyone? Is it clear to everyone, guys? Let me know, please. Is it clear to everyone? What assumption I am making over here? Okay. So what will be the mass of oxygen then? Oxygen ka mass becomes 56.36. So this is step number 1. This is step number 1. In the first step, what we are doing is, we are assuming total mass to be 100 gram. So percentage itself will become mass. Now once I have mass, what will happen? Once I have mass, I want to know the moles. What I want to know, Betaji? Moles. With the help of moles, what I am going to do, I will show you what I am going to do. So once I have the information of moles, so what will be moles? Phosphorus ka mass is 31. Phosphorus ka mass is 31. Molar mass 31 gram. And oxygen ka mass is 16 gram, right? So I have to find the number of moles. So number of moles, mass by molar mass. So which is 43.64 by 31, right? And what will be the moles of oxygen? So this is 56.36 by 16. Can you give me the numbers, Betaji, quickly? Can you give me the numbers, please? Do the calculation for me, please. What will be the numbers? 43.64 by 31. What is this number coming? So 43.64 divided by 31. This value comes out to be 1.4. This is 1.407, something like that. And if you divide this one, exact value I want, so that there is no calculation problem, 56.36 divided by 16, the value comes out to be 3.5 something. 3.5. Now, once I have the number of moles, what I want to know? Remember, what is the first thing? Assuming total mass to be 100 gram, so percentage has become the mass. Once I have the mass, I'll find the number of moles. Once I have number of moles, then what I want to do is, I want to have whole number ratio. What I want to have? Whole number ratio. For that, what to do? Listen better, very carefully, very, very important. What I want to do is, whenever we get these type of number, you take the smallest one and divide them by smallest number. Smallest mole, whatever we have, divide by that. So, if I divide by 1.407, this will be 1. I am talking mole ratio. What I am taking, Betaji? Let me erase this one. Okay. So this is mole ratio, okay. So we are having mole ratio. So mole ratio comes out to be 1. And if you divide, I think how much it will come, approximately 3 it will come, 3.5 divided by 1.4, 2.5 it is coming. Okay, very good. So this is 2.5. This is the mole ratio, right? Now once I have the mole ratio, what to be done? Now mole ratio, I want a whole number. To write the molecular formula, empirical formula, I need a whole number. But this is not a whole number. Most of the time you'll get a whole number, most of the time. But if you don't get the whole number, multiply by such a number so that we can actually have a whole number. So because you can never write, see this is phosphorus 1 and what is the oxygen 2.5. Does it look like good? Is it looking good, Betaji? Is it looking good? Definitely not. So we never write the decimals, right? So once you have the mole ratio, if it is not exactly whole number, you multiply by some numbers so that we can have the exact value. So what I'll do is I'll multiply by 2, so the value comes out to be 2 and this value is 5. So what is this compound? So take out the ratio. Phosphorus is to oxygen. What is the mole ratio? Mole ratio is 2:5. That means what is the empirical formula? Empirical formula comes out to be P2O5. Empirical formula comes out to be P2O5. Is it clear to everyone? Is this clear to everyone? What we are doing over here? I'll repeat once again. How we are proceeding? Listen carefully. So initially you consider total mass to be 100 gram. We consider total mass to be 100 gram. So percentage itself, the percentage itself will become, what it will become? Percentage itself becomes the mass, right? Percentage itself becomes the mass. Once we have the mass, you want to know the empirical formula, and in case of empirical formula, you write AX BY, right? So what is this X and Y? Are they masses? X and Y, are they masses? Definitely not. X and Y are the moles. So you, from the mass, what I'll do, I'll find the moles. So given mass by molar mass gives the moles. Once I have the moles, these are the decimal numbers, I don't want them. I want a proper whole number. So what to do? Divide by the smallest mole. Whatever is present, to all of them, divide by the smallest one. So I have divided by 1.4. So if I do that, I'll get the value 1 and 2.5. Once I have that, most of the time these numbers are okay. They will be whole numbers. If you don't get the whole numbers, multiply by such a number so that you exactly have whole number, which is 2 and 5. So phosphorus oxygen, what is the mole ratio? It is 2 and 5. So the empirical formula is P2O5. Is this empirical formula concept clear to everyone? Give me a thumbs up, guys. Let me see. Is it clear to everyone? Is this concept, empirical formula, how we are calculating, is it clear to everyone? Bolo beta ji, everyone, please. Is this calculation clear to everyone, how we are approaching empirical formula? Bolo. Okay. Very good. So now we have understood how to do the empirical formula. Now what we are going to do? How to find the molecular formula, sir? How to find the molecular formula? Now let me come to that. How to find the molecular formula? Okay, let us say that you did a calculation and you find the carbon-hydrogen ratio, and let us say, like how we have done the calculation over here, so percentage of carbon will be given, percentage of hydrogen will be given, everything is given, and you find the ratio 1:1. You find the ratio, listen carefully, beta ji, listen carefully. So carbon-hydrogen percentage by mass will be given, how it is given in this particular problem. From that calculation, we calculate a ratio to be 1:1. That means, what is the empirical formula? Empirical formula is CH. Empirical formula is CH. Now, this is not exactly molecular formula. So, what is the molecular formula? How to find that, sir? So, molecular formula, how to know that? So, definitely, I need some number, ki how many carbons and how many hydrogens are present. How to know that, sir? Please, very easy. So, in the question, you will be provided with the molar mass. What will be given to us, Bolo beta ji? Molar mass. Now, molar mass is not empirical mass. Molar mass is coming from the actual number of atoms. Let us say that the value of empirical mass is given 78 grams. What is given, Bolo? Molar mass of the compound given is 78 gram, and you are having empirical formula. Now, with the help of empirical formula, I can find the empirical mass. Definitely, I can find empirical mass. So, what is the empirical mass? Empirical mass comes out to be carbon and hydrogen. Kitna aa gaya bolo beta ji? 12 plus 1, 13. 12 plus 1, 13. Yes or no? Now, we are having a molar mass and we are having empirical mass. Now, can you give me molecular formula? With the help of molar mass and empirical mass, can you give me the molecular formula? Bolo beta ji, can you give me the molecular formula, anyone? Empirical formula is CH. Ratio was mole ratio 1:1. So molar mass is provided to you. I have given you the molar mass. Molar mass ka value I have given to you. Can you find molecular formula for me? Very good. C6H6. Very good, guys. Very good. Krishna, very good, beta ji. Very, very good. C6H6. Right. Now how we have done that? Total mass ka compound is 78 and 13 mass is there. So molecular formula will be, I can write like this. See, empirical formula, and in subscript there will be a number, is equal to molecular formula. What is this n value? So if I have CH and if I multiply by this number, I will have molecular formula. Let us say n ka value comes out to be 6. So what will be the formula? C6H6. Now the whole thing is how to find the n value. The whole thing is how to find the n value. Very easy. N value is equal to, what is the n value? Molar mass by empirical mass. Very simple, right? Very, very easy, isn't it? Empirical mass. So if you divide that, you'll get a number. You'll get a number, and if you multiply that number in subscripts with the molecular formula, empirical formula, you'll get the molecular formula. I hope very easy, right? Everybody understood, right? I knew the empirical formula, so I know the empirical mass. What is given to us? Molar mass. Divide कर दो, कितना number आ गया? 6. That means you need to multiply by 6. So this is C6H6. Compound comes out to be C6H6. Is this clear to everyone? बोलो बेटा जी. Is this clear to everyone? Let me see. Is it clear to everyone? Bolo. Is this clear to everyone? Can we go for the next topic now? Is it clear to everyone? Molar mass by empirical mass will give a number. Will give a number. And that number, if you multiply, you get the molecular formula. Okay. Sometimes molar mass will not be given. What will be given? Vapor density. Molar mass will be not given. What will be given? Vapor density. Now, can we find the molar mass by vapor density? Can we find the molar mass by vapor density? Yes or no? Give me the formula quickly. How to find the molar mass by vapor density? Vapor density is given. Molar mass is not given. Molar mass is not given. We are provided with the vapor density. Very good. 2 into molar mass. Very, very good, beta ji. Yagnashri, very good. So we know that vapor density is equal to molar mass of the gas by 2. So if vapor density is given, not into 2, beta ji. Vapor density is equal to mass of gas by 2. Mass of gas by 2. So vapor density will be given, and 2 into vapor density will give the molar mass. I think very easy, all of you understood, right? So sometimes mass will not be given. What will be given? Vapor density. That is why we have studied vapor density, and it is more useful in different chapters, okay? And this is very, very easy. I hope this is clear to everyone. We'll solve few more problems now. Okay, so let me see. Solve this one quickly. Percentage composition ka question. We'll solve few more problems to understand all these things. Percentage composition. So what is the percentage composition by mass of each of the element? So you have to find percentage composition carbon, percentage hydrogen, and percentage oxygen. This is called as fumaric acid. इसका structure कुछ ऐसा होता है. This is the structure of fumaric acid. Double bond, COH, H and H. Okay, most of you won't be knowing all these things anyway. Why I'm confusing you? Leave this. So this is the compound fumaric acid, and give me the value. Percentage carbon, percentage hydrogen, and percentage oxygen. Give me the values better quickly. Solve everyone. Solve करिए. What is the molar mass? What is the molar mass? So 4 hydrogen plus 12 into 4 for carbon plus 16 into 4. So this is the molar mass, that is the total mass we are having. Give me percentage of carbon. 600 by 13%. 600 by 13%. So this is 12 into 2, कितना हो गया? 12 into 4, 48, and this is 4 and 64, right? So कितना हो गया? 4, 4, 8, 16, 6, 4, 10, 116. Percentage of carbon, so this is 4 into, what is the carbon ka mass? 12 by 116 into 100. I think very, very simple. 48 by 116. Exactly what is the value coming, beta ji? What is the exact value coming? 48 by 116. So this is 41.3% is coming. Very good. 41.3, 3.4, 55.5 total value. If you'll sum that, yeah, approximately yes. Very good. Moti, whatever wave you have written. Very good, beta ji. Very good. Okay. I think all of you understood, right? Percentage composition. Is this question clear to everyone? Can we go for the next one? Can we go for the next one? Is this clear to everyone? Bolo beta ji. Is this problem clear to everyone? Can we go for the next one? So percentage hydrogen 4 into 1 by 116 into 100. Percentage oxygen 4 into 16 by how much? 116 into 100. So this is percentage oxygen, this is percentage hydrogen, this is percentage carbon. We'll go for the next one, okay? Okay, great. Okay, let's see. Okay, so this is a problem we are having. Please listen carefully. Without doing detailed calculation, so you should not use calculator, you should not do any calculation, okay? Without doing a detailed calculation, estimate whether the percentage composition by mass of strontium is greater than or smaller than that of oxygen. So it is asking strontium ka percentage mass is more or oxygen ka percentage mass is more in the given problem. What is the atomic weight of strontium? Let me see what is the atomic weight of strontium once. Mass of strontium. So mass of strontium is 87. Atomic weight of strontium is given 87. If you have having one atom, AMU, if 1 mole grams. Oxygen, very good beta ji. Very good. Very simple, right? So oxygen, how many oxygens are there? 2 into 3. So 6 oxygens into their mass, which is 16, which is how much? 96. And strontium ka mass is 87, and which is single. So of course, more mass, more percentage composition. More mass, more percentage composition. Less than that of oxygen. Less than that of oxygen. I think very simple, right? Is it clear to everyone? Oxygen, right? Very simple, right? I hope clear to everyone. Should we go for the next one now? We'll go for the next problem, okay? Should we go for the next one? Okay. Okay. That is the difficult one. I will go for that later. Okay. So we are having this problem. Okay, I have a very good problem actually. Let me see. Very great problem. Okay. What is this? No. Very good question. Yes, do this one. Let us see how many of you can solve. Please try this one. Peroxyacetyl. No, this is acyl. Acyl, both are same actually. So peroxyacetyl nitrate is one of the components of smog. You all know smog, right? You all know smog. What is smog? Smog, smoke plus fog. So this is a major component for the pollution. You'll study in environmental chemistry. Preparation of PAN is also there, peroxyacetyl nitrate. Please read this problem and please solve this. Please give me the answer for this. What should be the, molecular formula? What is the molecular formula? And we are provided with molar mass. You have to tell me the molecular formula. Go ahead guys. Let's see how many of you can solve. Is this question clear to everyone? Give me a thumbs up. Is this problem clear to everyone? Give me a thumbs up quickly and then solve. Is this problem clear to everyone, guys? Please let me see. Is it clear to everyone? C is repeated. Oh, C is repeated 2 times. Where it is? Carbon, hydrogen, nitrogen and oxygen. 19. Okay. So that is carbon. 19.8% is the carbon. 2.5% is the hydrogen. 11.6. This is nitrogen. Okay. This is nitrogen. Carbon, hydrogen and nitrogen. Okay. So your doubt will be what will be oxygen then, right? Can you give me the oxygen ka percentage? So total percentage 100. Total percentage 100. You add these values and you subtract by 100. You add all the percentage and subtract by 100, you will get the percentage of oxygen. Okay. So this is 11.6 percentage of nitrogen. Percentage of nitrogen. Go for it now. percentage of nitrogen. 11.6% nitrogen. How to find the percentage of oxygen? Because there are 4 elements: carbon, hydrogen, nitrogen, oxygen. Oxygen is not mentioned to us. Because oxygen is not given, you add total, 100 minus total, that will be percentage. Go for it. 33.89, whatever it is. So somebody is saying 33.8, whatever is the value, give me the formula. Give me the formula, guys. 66.1, right? Yes. So percentage of oxygen, 66.1%. Give me the formula, guys. Give me the molecular formula. C2H3NO5. I don't think so. NO5 should be there. Maybe, we'll see. I think you're correct, Yagnasri. I think we'll see. You're not searching on the Google, right? What is the formula of PAN? You are not doing that, right? You are not doing it, right? You are simply looking at the peroxyacetyl nitrate ka formula and you are giving me the formula. Don't do that, beta ji, please. Solve the problem. Shreya, have you solved it or simply looked at the Google, the formula? Don't look at the formula from the Google, please, because that is the wastage. Otherwise, what is the point of doing all these things? Okay, go ahead. So, some of you are getting the answers. Let's see how many of you are doing correct. Do it. Let's see. Please solve it. Got it, sir? Very good. C2H3NO5. Very good, beta ji. Empirical formula is C2H3NO5. Empirical formula, definitely. If you calculate the molecular formula, how to calculate the molecular? Let me go for the calculation now. See, beta ji, you calculate the total mass. C2H3NO5. If you calculate the mass, iska mass will be, I think, approximately 120 gram. So because the mass is same for the empirical mass, so the formula itself will become molecular formula. So the formula itself will become molecular formula because the mass of the empirical formula and molecular formula both are same. So the empirical formula itself is molecular formula. Clear to everyone? Okay, let's do it. We'll go for it. Let me write now the table and let's see. We'll solve this problem now. Okay, so we are having what atoms? We are having carbon, hydrogen, nitrogen and oxygen. So first we will write the mass. We are going to write the mass. So total mass we have assumed 100 grams, right? So carbon is given 19.8. Okay, 2.5% of hydrogen. So 2.5 gram hydrogen. 11.6 carbons, that is nitrogen, 11.6, and the remaining 66.1 grams is the mass of oxygen. So what are the moles? Give me the value of moles, beta ji, quickly. What is the mole for carbon? Give me the mole of carbon, please. Moles of carbon. I want exact values, otherwise it won't come. So 19.8 divided by 12, right? So 1.65 is the moles of this one, right? So what is the mole of hydrogen? Divide by 1. So this will be 2.5 moles. For nitrogen, 11.6 divided by 14, right? So this is 0.828. And for oxygen, 66.1 divided by 12, right? So this is 5.5. This is 5.5. So these are the moles ka ratio. These are the moles ka ratio. Now, I want to have a whole number, right? So because I want to have a whole number, I will divide by the smallest one. And what is the smallest one? 0.828. So ratio I want to have ratio. So 1.65 divided by 0.828. Similarly, 2.5 divided by 0.828. This will be 1, and 5.5 divided by 0.828. I think if you divide, this value comes out to be approximately 2. 8 to the 16, right? So this will be approximately 2. 8 3s are 24, right? 8 3s are 24. So approximately this will be 2. 3, right? 8 3s are 24. And 1, this is anyway 1. and 0.8, 8 6 तो कितना हो जाएगा बोलो बेटा जी? What is this? 5.5 approx value. So 5.5 divided by 0.8. So it is coming approximately how much? 7, right? Oxidation. 66.1 divided by 16, 5.5. 5.5 by 0.828, 6.64. Are we doing any mistake over here? This should be 0.5, right? This should be 5. 66.1, this will be 5.5. Are we doing any wrong mass? Wrong mass for what, bolo beta ji? This is wrong, 66.1. What is this mass? 66.1 by 16, 4.125. Okay. So by 16, she is saying 4.125. Okay. So this is 4.125. Please do the calculation. 4.125. So 4.125 by 8540. Yes. So this is 5. So the formula comes out to be C2H3, C2H3, nitrogen 1 and O5. Now this is the empirical formula. Remember, this is not the molecular formula. This is the empirical formula, right? This is the empirical formula. Can you give me the mass of empirical formula? What is the empirical mass? What is the empirical mass? Give me the empirical mass quickly, please. Give me the empirical mass, please. Give me the empirical mass. What is the mass coming? Empirical mass. What is the empirical mass for this compound? 121. Very good, beta ji. So this is 121. Empirical mass is 121 and the molecular mass is 120. So how we calculate N value? N value, molecular mass or molar mass by empirical mass. Yes or no? What is the molar mass? 120. And what is this? Approximately 120. The value will be approximately 1. Therefore, empirical formula itself is molecular formula. Empirical formula itself is molecular formula. Empirical formula itself is molecular formula. Give me a thumbs up. We'll finish the class here, and tomorrow we'll solve few more problems over here, and then we'll start with the next topic. Tomorrow we'll solve few more problems. Is it clear to everyone? Give me a thumbs up. Let's see how many of you have understood. Is this clear? Have you learned the concept of percentage composition as well as empirical formula and molecular formula? Is it clear to everyone? Okay, great guys, great. I hope all of you are loving it. Yes, this is very, very important, very simple, right? Bye everyone, bye, take care. If you get the PDF, solve few more problems. If you get the PDF in the Telegram, please go through it once, okay? And solve more problems. Anyway, we'll do few more problems tomorrow and we'll continue for the next topic. Thank you so much. Bye everyone. Bye bye. Thank you.